Good afternoon, everybody. I'm Helen.
And I am Arundhati.
Welcome back to the afternoon session of Day 2 of Project Expo. I welcome Honorable Judges Abhilash Suryan Sir, Shafiq Sir, and Pradeep Sir, and the other profession committees to this magnificent event. This is Project Expo running under E-Novus, authorized by Innovation and Entrepreneurship Development Center in association with Institutions Innovation Council. As we already witnessed so many mind blowing projects and creative solutions for the existing problems by the competitors here, we can move on to the rest of the session by resuming the Project Expo on the concept Aid for Differently Abled People.
That was refreshing. Thank you, Helen. Before we start, I request all the teams to strictly follow the time slots. That is 15 minutes for presentation and 5 minutes for judgment. Now, I welcome Captain Ashwin, boss, and team to elicit the idea.
So good afternoon, judges, and my dear friends. Myself, Ashwin Bose, first year EEE CET, and let me share my screen.
Myself, Govind there, pursuing undergraduation in artificial intelligence and machine.
Hope the screen is visible. So here we are here to present our project, Advanced Specs for the Visually Challenged. So let's move on to our topic. So these are our features of our advanced specs: self-recognizing virtual braille script, face mask recognition, optical sensing, uneven surface shading system, emergency photo service, and audio assistance. All these features run parallelly in our specs. So these are our components of our specs: Python-based single board computer chip, lithium battery, button switch, camera module, earphone capsule, ultrasonic sensor, ultrasonic detector, memory card, battery charging port, 3D printed polymer frame. Govind, you are not audible.
Okay, so during these tough times, the most affected and least recognized community were our visually challenged friends. So, why self-recognizing virtual braille script? In the present world, the visually challenged community access the public braille system using their fingers, which can create a huge health hazard by spreading COVID-19 vaccine. And the main highlight of our project is replacing the braille script using. Hello?
Yes, you are audible.
Yeah, okay. So replacing the braille script system by a virtual QR code system and preventing the hazardous using fingertips. So our alternative is replacing them with QR code, and our motto is replace go contactless. So how? So how are we going to execute this program? That's what I'm going to explain. So first of all, we activate our ultrasonic detector and it begins browsing for presence of a specific x86 megahertz frequency. That means it should be a unique frequency, and moreover we also require a systemic support from both private and public institutes to spread this facility. And using the four navigation commands forward, backward, right, and left, the person could reach to the correct location of the QR code onto which the frequency tag will be based upon. This avoids conventional method of searching the script by moving fingers everywhere, and as I already mentioned, it's a huge health hazard. And once the QR code is scanned, the text is read using PYTTSX3 library, and it waits for 2 seconds. If the person moves on, then it will start searching for the next QR code. If the person remains there, that means the person is not clear with the text read, so the system will once again read that to him. So here, this is the Python code for the same I explained just now. Here, using OpenCV library, we access our camera. That means the front camera, and you can see a zero. That means we are connecting to the default camera. We take each frame as a picture and decode the QR code using PyZR library module. we give value of data variable as just the beginning part of the code, as we only need the main text part, while PyZbar module will also provide many unnecessary informations like metric size in area, centimeter square or millimeter square. Also, it also provides the digital size in bytes. So PYTT-SX3 bar reads the text which is written in a data variable. So the two pictures of our cat from two different angles are shown here. This demonstrates the position of camera and power button along with the earphone module. And we can see the camera is placed in a toroid cushion in the center, protecting it from environmental stress while falling. So why face mask recognition? Its significance is something I need not explain, as it's the first line of defense for our breathing system. So how are we going to execute this program? So we open the camera, take each frame as a picture, the same way we did last time, and take it to a neural network. We standardize the size as 10 into 10. That's the standard size. We change it for all the pictures. The next step is normalizing the color. We divide each color coordinate of the metric cell using 255, because 255 is the maximum limit of a color coordinate. By doing this, we are able to get the color coordinate between 0 to 1. That means red color gives 255, 0, 0, while dividing that by 255, it gives 1, 0, 0. In this way, it will be easier for the neural network to process. So here we are showing the algorithmic part. So we can see that the trained data after normalizing 100 pictures, each with and people without mask, the neural network trains it using Keras library module. If the computer detects a human face, it will check the next step whether the person is without mask or wearing mask. If the person is wearing mask, the program starts again. If the person is not wearing the mask, then the program will warn him using PYTT as a library. So here we are showing the code for the same, and without mask its value is taken as true, while wearing mask it's taken as false. In the following code we are normalizing colored size as mentioned previously, and we are also importing 100 image. You can see the location mentioned of those 100 pictures from the C drive. We are all doing this with the support of Keras model, and it's a crucial component of this neural network. And like the same previous features, at the end by PYTT-SX3 library, we take the word please keep distance, no mask. So we can see the same picture we mentioned earlier, as this feature also uses the same components. So we can see the same image here also.
So this is our next feature, that is obstacle sensing. So we are using an ultrasonic sensor for this purpose. An ultrasonic sensor generates ultrasound and then it receives back after reflecting from an obstacle. So how does this work in our specs? First, the specs is on, the ultra module sensor gets activated. Then it searches for obstacle. If an obstacle is found, then it checks whether the obstacle is within 50 centimeter. If either of the cases are false, then it goes back to search for obstacle. After checking if the obstacle is within 50 centimeter, if it is so, then it reads obstacle ahead using the PYTT-SX3 module. And after that, if the power button is pressed, then it goes to stop. If it is not pressed, then it goes to search for the obstacle after waiting for 2 seconds. So this is the obstacle sensor that we have kept in our specs.
So this is the logic behind you walking through uneven surface. So here we can see that when the specs is turned on, the initial distance is recorded and saved. So till it is saved till the next time the specs is turned off, and it will remain the stored data till next time it's turned off. That means it is a temporary memory. So we can label it as X. So as the person proceeds, when the user faces some obstacle, the distance between the obstacle and the source changes. If that value goes out of the range of x minus 5 to x plus 5 centimeter, that means the person is passing through uneven area, and that alerts the user.
How does this work? First, the specs is on, and then the ultra module sensor gets activated. It then searches for obstacle. If an obstacle is found, then it calculates the distance from the obstacle and saves it. After that, the distance between the obstacle and the sensor is found. If that distance is within the range x minus 5 and x plus 5, it goes back to search for obstacle. If it is not within this range, then it reads uneven surface ahead using the PYTTS63 module. After that, if the power button is pressed, then the spec stops. If it is not pressed, then it goes back to search for obstacles. So this is the obstacle sensor that we have kept. We have provided it at an angle of 45 degrees to the horizontal axis. So this is our next feature, emergency photo service. So a visually challenged person is more vulnerable to face robbery. So we have provided this emergency photo service so that at least we could take a photo at that incident. In this way, we can reduce chances of being robbed. So how does this work? First, the device is on, and then the video camera is activated via OpenCV. If the emergency button is pressed, then it takes a photo and saves the image as emergency.png. After that, if the power button is pressed, then the device stops. If it is not pressed, then it goes back to activate the video camera. So this is the code for our emergency pick. First of all, the time library is imported. Then the emergency pick is initialized. Then the variable A is initialized. If the button is pressed, then the value of A is incremented. Then the frame reads the image at that time. And there is 0 seconds. There is no time limit between two consecutive pictures. And then the emergency picture is saved as emergency.png, and the last statement specifies the button that we are using for this purpose. So this is the camera and the emergency button that we have provided in our specs.
So a visually challenged person can access the knowledge or the information around him by two means. The first one is using hearing, the second one is by touching. And touching means the conventional principle of braille script, and here we are replacing it with hearing system. So we are going to explain the significance of audio assistance in our specs.
So how does this work in our spec? So using the PYTTS63 library module in the Python, the text read or pre-written are converted into speech and dictated via the earphone. So this is one of the most important component in our specs. Almost all other features use this part for their functionality. So this is the earphone that we have provided. It is attached to a gear which is further attached to our specs.
So here you all could see the CAD of our model. So you could see the cam placed in a toroid position which protects it, as I mentioned earlier. In the left leg you could see there's two pointing sensors out. One is to sense the vertical obstacle, and other one is placed diagonally, that's 45 degree with horizontal plane. It helps the person pass through uneven area, and you could also create a red button, that's the emergency photo button. Next to that, you could three cells, that's replaceable lithium-ion battery button, so that we could replace it once the charge gets exhausted. While shifting to the other left, we could see a casing where our main single chip Python-based computer is placed, and we could also see a gear via which an earphone module is placed. So finally we could see a red color button on this side, and that is the power button. So this is our CAD representation. So what makes us special? That's the main highlight. Standalone device. We don't require any internet, and we only require the specs as a simple unit, and we don't have any component. We don't need any requirement of mobile phone or internet. That means we can use our specs anywhere on this planet. So battery in every hour, in every hour the battery charge will be measured, and it will be informed to the user about the charge left every hour. Once the charge falls below 25%, the person will be alerted every 15 minutes about his battery life. And Wi-Fi and Bluetooth are highly charge consuming, so we are avoiding them purposefully to increase the battery life.
So why are we using this conventional shape? So this is the dimension 15 centimeter into 15 centimeter into 5 centimeter. The weight is equally balanced in our specs. The battery case exposed but covered so to replace the battery with charge spare if couldn't be charged on time. And keeping front lines unoccupied so as to prevent complete strain on the facial muscles. So these are our references. Thank you.
So we have presented the problem, algorithm, program, CAD, and the concept of our project. Thank you.
Thank you, team. Now let's have discussion with the judges.
Okay, I'm Pradeep. Okay. So, how long can you detect any obstacle through this lens or through this spectacle?
Yeah, we have mentioned that 40 centimeter.
So, 40 centimeters is very short.
Okay, so do
We
you mean the
cannot get
obstacle or QR code?
sufficient time to react if there is any obstacle. 40 centimeters is very less.
Okay, sorry. I heard as I was speaking about QR code. Obstacle, it's written 5 meter. I was talking about QR code
Okay, 5 meters is
centimeters.
okay. 5 meters is okay. And in your slide also it is mentioned like 50 centimeter.
Sir, that's I have mentioned that in that QR code system where the
Okay,
specs
okay.
could scan that.
QR
Yeah,
code system. Okay, okay. So, what is the significance of that 45-degree angle for the camera?
yeah, yeah. For if a person is climbing up a stairs, his initial distance, diagonal distance will keep on changing. If it goes out of the range of the initial distance plus or minus 5 centimeter, that means the person is passing through some hurdle or some object is there 45-degree downwards. We are using this to avoid use of walking stick.
Okay. What about the you already told that there is no need of internet or those things. So, what about the reliability of this product? Are you able to make a prototype? And what is the material used there? Is it plastic material? Hello, can you hear me? Hello?
Yeah, I can hear. Yes, sir. We use PPA polymer. We can
PP.
3D print the structure.
Okay, you are 3D printing the structure. Okay, okay. Then how will you fix the components inside the structure? If we are planning to
Sir,
3D print. Sir, you
yeah,
are
yeah.
uh,
Okay. Sir, you can continue.
okay, okay. You continue.
Okay, so we are using a single chip compute Python based computer, that means something like Raspberry Pi, so that we can use the normal wiring, but we will put inside the 3D printed case.
So you are 3D printing component by component, right?
Not component, the outer case, and we will use the hardware component. We will buy that from outside and we will place it. Only the structure is 3D printed.
So entire structure is 3D printed, right?
Yeah, covering.
Covering. Okay, okay. Okay, I have some doubt there. Okay, still no problem. Okay, that's all from my side. Okay.
Okay, I am Shafiq. What will be the total cost of this product?
Yeah, the
Hello?
total. Yeah, I can hear. I can hear. If it's like a large number we are making using machines, it will be lesser. But as of now, it might cost somewhere between 2,000 and 3,000 because the components are a bit expensive.
Hmm. All the parts will be mounted on the 3D printed casing?
The Raspberry Pi system will be placed inside that casing on the right leg, while other parts will be also placed in the specific area mentioned in the figure, where it could be placed inside the 3D printed casing.
What will be the total weight?
Yeah, weight will be around 200 grams because we are using a lightweight PPA polymer. So the only weight which will be seriously affecting will be that of the battery and the Raspberry Pi chip, and it will be around 200 grams altogether.
So next you have to do the 3D printing and make the prototype. Currently you don't have a prototype.
We currently we don't have the Raspberry Pi chip. We have the components, but we don't have the Raspberry Pi chip, and we also doesn't have any access to 3D printing right now. We have done the programming and run that on the PC, but for running on Raspberry Pi, we didn't have that Raspberry Pi module currently with us.
Okay, it's from my side.
Again, a very good and novel idea. So I would like to ask about how your device will be planted, or how comfortable it will be for the user to wear.
First of all, we also need a systemic support from private and public institutions.
No. Have you? My question is: suppose I am wearing the normal specs, so I will be wearing on my face supported on the ears, right?
Sir, this one is specifically for blind or the visually challenged.
So how you are planning to make it comfortable for them to wear?
Yeah. The main highlight is we are replacing the existing braille system at public places using the QR code. So they need not touch and create health hazard for them, exposing themselves to COVID virus. They can just scan that from 40 centimeter apart.
That is okay. That is okay. But by looking at your diagram that you have shown, I could not see how they will be able to wear it. I could not see maybe how to mount it on their ear or.
This is as a unit. It can be worn the same way we wear a conventional spectacles, the same way.
But can I see your diagram? Can I see your diagram?
Okay. Yeah.
Please advise the participants not to stop the presentation because we may have to ask some query based on the presentation. So looking at this diagram, how it will be worn by the user?
It has the same two legs like any other conventional specs, so that it could be worn this.
Huh?
How much? Yeah, sir, I couldn't hear how much.
Look at the design, whether it is taken into account the possibility for a person to wear it comfortably without falling off, especially a blind person.
Okay, so we have placed a gear with earphone in the right side, and the other side we have placed battery spaces with which can create a grip to his ears, and we have also used this shape because it doesn't involve the pressure not only on front side. The pressure is equally distributed on all three sides.
Okay. Then there are many such devices already existing in the market. Have you looked at such devices? Not exactly very popular, but some devices are already available. So have you looked at some of those devices and what difference your device is having compared to those
Okay, so none of the existing devices have the facility to replace braille script with QR code and read them to the user. And the second one is that existing specs doesn't have the facility to check whether the person is wearing mask or is without mask.
Are you sure?
We have searched the internet. There is nothing like replacing braille script with QR code system.
Okay, then how you got the idea?
Initially, once I was reading about how QR code system originated. It was actually invented in a car manufacturing factory in Japan, where initially they have to sign each label of the automobile part, but the owner of that plant replaced it with QR code system, making it easy. So I took idea from there and placed here.
Okay, thank you. Good.
Thank you. Now I welcome Captain Mohammad Rishan NK and team to present. And as Sir said earlier, all the teams please keep presenting. You can stop sharing once the discussion is complete.
Is the screen visible and audible?
Yes.
Good afternoon, all. My name is Mohammed Rishan and I am from Government Engineering College, Thrissur. In this E-Novus Project Expo 2020, I am presenting or I am exhibiting the project called Humanoid Teaching Robot for handicapped teachers and students. Okay, can I continue with Malayalam? Is there any issue?
Yes, you can go with Malayalam, but your voice is breaking.
Okay, fine. Voice is breaking. Is it okay
Yes. Now it's okay.
now? Okay. അതായത് നമുക്ക് ചുറ്റും നോക്കിക്കഴിഞ്ഞാൽ ഒരുപാട് ഹാൻഡിക്യാപ്ഡ് ആയിട്ടുള്ള ടീച്ചേഴ്സ് അല്ലെങ്കിൽ ഹാൻഡിക്യാപ്ഡ് ആയിട്ടുള്ള സ്റ്റുഡൻസ് അവർ പഠിക്കാൻ വേണ്ടി ഒരുപാട് ബുദ്ധിമുട്ടുന്നുണ്ട്. അവർക്ക് പല ചലഞ്ചസും നേരിടേണ്ടി വരുന്നുണ്ട്. പല സിറ്റുവേഷനിലും അവർക്ക് പഠിക്കാൻ കഴിയാത്ത അവസ്ഥ. അപ്പം അവരുടെ ഇഷ്യൂസ് മനസ്സിലാക്കി അതിനെ സോൾവ് ചെയ്യാൻ വേണ്ടിയിട്ട് അവർക്ക് ഇപ്പം ഓഡിയോ ക്ലിയർ അല്ലേ?
കുഴപ്പമില്ല.
ഓക്കെ ഓക്കെ ഫൈൻ. ഓക്കെ, അപ്പം അവർക്ക് പല ചലഞ്ചസും ഫേസ് ചെയ്യുന്നുണ്ട്. പഠിക്കാൻ പറ്റാത്ത സാഹചര്യം, അവർക്ക് വരക്കാന് അവരുടെ കാര്യങ്ങൾ സാധിക്കാൻ പറ്റാത്ത അവസ്ഥയുണ്ട്. അപ്പം ഈ സാഹചര്യത്തിൽ അവരെ മീറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ടുള്ള ഒരു റോബോട്ടാണ് നമ്മൾ പരിചയപ്പെടുന്നത്. അവരുടെ കഴിവുകൾ, അവർക്ക് വരക്കാനുള്ള ഒരു എക്യുപ്മെന്റ്, അവർക്ക് പഠിപ്പിക്കാൻ, അവരുടെ ഡൗട്ട്സ് ക്ലിയർ ചെയ്യാൻ, അവരുടെ അറ്റൻഡൻസ് എടുക്കാൻ വേണ്ടിയിട്ടുള്ള ഒരു റോബോട്ടാണ് ഇന്ന് എക്സിബിറ്റ് ചെയ്യാൻ പോകുന്നത്. അപ്പൊ നമ്മൾ ഛത്തീസ്ഗഡിലെ കേസ് എടുക്കുകയാണെങ്കിൽ അറൌണ്ട് 1044 ടീച്ചേഴ്സ് അവർ ഹാൻഡിക്യാപ്ഡ് ആയിട്ട് അവർ സഫർ ചെയ്യുന്നുണ്ട്. ഇപ്പൊ നമുക്ക് ലോകത്തിന്റെ കേസ് എടുക്കുകയാണെന്നുണ്ടെങ്കിൽ നമുക്ക് ഊഹിക്കാവുന്നേ ഉള്ളൂ. അപ്പം അത്രത്തോളം ഹാൻഡിക്യാപ്ഡ് ടീച്ചേഴ്സ്, സ്റ്റുഡൻസ് ഉണ്ട്. അപ്പം ഈ ഒരു കേസിൽ ആ സ്റ്റുഡൻസിനെ ഹെൽപ്പ് ചെയ്യാൻ വേണ്ടിയിട്ടാണ് നമ്മുടെ റോബോട്ട് ഹെൽപ്പ് ചെയ്യുന്നത്. ഇതില് ഒരു മൈക്രോ പ്രൊസസർ ഉണ്ട്, 3 മൈക്രോ കൺട്രോളേഴ്സ് ഉണ്ട്. അപ്പം ഈ ഡിവൈസസ് ഒക്കെ രണ്ടെണ്ണം നമുക്ക് IoT വെച്ച് കൺട്രോൾ ചെയ്യാം ത്രൂ ആൻ ആൻഡ്രോയിഡ് ആപ്ലിക്കേഷൻ. അപ്പോൾ ഈ ഒരു പ്രൊജക്ട് നമ്മൾ 23 ദിവസമാണ് ഉണ്ടായിട്ടുള്ളത്. അപ്പൊ നമുക്ക് അതിന്റെ വർക്കിംഗ് വീഡിയോയിലോട്ട് പോവാം. ഇതാണ് നമ്മുടെ കംപ്ലീറ്റ് ഹ്യൂമനോയിഡ് ടീച്ചിങ് റോബോട്ട്. ഇത് മെയിൻലി 5 ഫങ്ഷൻസ് ചെയ്യും. അതായത് നമ്മളിത് ജസ്റ്റ് ഒരു പ്രോട്ടോടൈപ്പ് ഡെവലപ്പ് ചെയ്തിരിക്കുകയാണ്. ജസ്റ്റ് ഒരു അയൺമെന്റ് രൂപത്തിൽ ഒരു പ്രോട്ടോടൈപ്പ് ഡെവലപ്പ് ചെയ്തിരിക്കുകയാണ്. ഇതിന് നമുക്ക് എന്ത് ഡൗട്ട്സ്, ഫസ്റ്റ് ഫംഗ്ഷൻ ഇസ് ദാറ്റ് ഇതിന് എന്ത് ഡൗട്ട്സ് ചോദിച്ചു കഴിഞ്ഞാലും ക്ലിയർ ചെയ്ത് തരും. നമ്മള് എനി ഡൗട്ട്സ് അല്ലെങ്കിൽ കുട്ടികൾക്ക് എന്തെങ്കിലും ഡൗട്ട്സ് ഉണ്ട് എന്നുണ്ടെങ്കിൽ അത് നമ്മൾ ചോദിച്ചു കഴിഞ്ഞാൽ അത് ആൻസർ ചെയ്തു തരും. ആൻഡ് ദ സെക്കൻഡ് തിങ് ഈസ് ദാറ്റ് അത് കുട്ടികളുടെ അറ്റൻഡൻസ് എടുക്കുക, ഫിംഗർ പ്രിന്റ് വെച്ച് കുട്ടികളുടെ അറ്റൻഡൻസ് എടുക്കുക. അതാണ് രണ്ടാമത്തെ ഫംഗ്ഷൻ. മൂന്നാമത്തെ ഫംഗ്ഷൻ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇത് വരക്കും. ഐ മീൻ കുട്ടികളെ വരക്കാൻ ഹെൽപ്പ് ചെയ്യും. ഐ മീൻ അവരുടെ പിക്ചേഴ്സ്, സർക്യൂട്ട്സ്, അങ്ങനത്തെ കാര്യങ്ങളൊക്കെ വൈറ്റ് ബോർഡിൽ പ്ലോട്ട് ചെയ്ത് തരും. പിന്നെ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഇത് ആൻഡ്രോയിഡ് ആപ്ലിക്കേഷൻ ഉണ്ട്, അത് വെച്ചിട്ട് ഇത് കൺട്രോൾ ചെയ്യും. നമുക്ക് ഇതിന്റെ കാര്യങ്ങളെല്ലാം കൺട്രോൾ ചെയ്യാം. അത് കംപ്ലീറ്റ് വീഡിയോ മനസ്സിലാവും. ഓക്കെ, ആദ്യമായിട്ട് നമുക്ക് അതെങ്ങനെയാണ് വരക്കുന്നതെന്ന് നോക്കാം. ഇങ്ക്സ്കേപ്പ് എന്ന് പറയുന്ന ഒരു ആപ്ലിക്കേഷൻ ഉണ്ട്. അപ്പൊ ആ ആപ്ലിക്കേഷൻ നമ്മൾ ഏതൊരു ഫയൽ ഇപ്പൊ സർക്യൂട്ട് ആയിക്കോട്ടെ അല്ലെങ്കിൽ ഒരു ഇമേജ് ആയിക്കോട്ടെ അത് ഇൻസെർട്ട് ചെയ്ത് കൊടുത്തു കഴിഞ്ഞാൽ അത് ജി കോഡിലോട്ട് കൺവേർട്ട് ചെയ്യും. ജി കോഡിലോട്ട് കൺവേർട്ട് ചെയ്ത് കഴിഞ്ഞ് നമ്മൾ ഇതിലോട്ട് അറ്റാച്ച് ചെയ്ത് ഇതിലോട്ട് ഇന്റർഫേസ് ചെയ്തിട്ടുള്ള CNC പ്ലോട്ടർ നമ്മുടെ റോബോട്ട് വരച്ചു തരും. ഓക്കെ, ഇതിൽ നമുക്ക് വേണ്ട ഇമേജസ് കൊടുത്തു കഴിഞ്ഞാൽ ഇത് നമ്മുടെ പ്ലോട്ടർ ആണ്. ഈ പ്ലോട്ടർ ഡയറക്ഷനിലോട്ട് മൂവ് ചെയ്യും. അങ്ങനെ ഇത് വരയ്ക്കും. ഇത് നമ്മൾ യൂസ് ചെയ്യുന്ന ആർഡിനോ മൈക്രോ കൺട്രോളേഴ്സും വിത്ത് ഇറ്റ്സ് ഷീൽഡ് ആൻഡ് 2 സ്റ്റെപ്പർ മോട്ടേഴ്സ് ആൻഡ് 1 സ്റ്റെപ്പർ മോട്ടേഴ്സ്. അപ്പൊ ഇത്രയും കമ്പോണൻസ് ഇതിൽ യൂസ് ചെയ്തിട്ടുണ്ടെങ്കിൽ നോർമൽ ആർഡിനോ സി കോഡിംഗ് വെച്ചിട്ടാണ് ഇത് പ്രോഗ്രാം ചെയ്തിട്ടുള്ളത്. പിന്നെ ഇതിന് വേണ്ട ജി കോഡ് നമ്മുടെ ഇങ്ക്സ്കേപ്പ് ആപ്ലിക്കേഷനിൽ നിന്ന് ജനറേറ്റ് ആവുന്നതാണ്. അടുത്ത് നമ്മൾ ഇതിന് ഒരു ആൻഡ്രോയിഡ് ആപ്ലിക്കേഷൻ ഉണ്ടാക്കിയിട്ടുണ്ട്. MIT ആപ്പിൽ നമ്മൾ ഒരു ചെറിയ ആപ്ലിക്കേഷൻ ഉണ്ടാക്കിയിട്ടുണ്ട്. ഇത് വെച്ച് നമുക്ക് ഈ റോബോട്ടിനെ കൺട്രോൾ ചെയ്യാനുള്ളതാണ്. ദിസ് ഇസ് അവർ ആൻഡ്രോയിഡ് ആപ്ലിക്കേഷൻ. അപ്പം ഫ്രണ്ടിലോട്ട് മൂവ് ചെയ്യാനുള്ള ബാക്കിലോട്ട് മൂവ് ചെയ്യാൻ ലെഫ്റ്റ് റൈറ്റിലോട്ട് റോബോട്ട് കൺട്രോൾ ചെയ്യാനുള്ള സിസ്റ്റം. ഈ സെന്റർ പാർട്ട് എന്ന് പറയുന്നത് ഇത് നിൽക്കി കഴിഞ്ഞാൽ നമ്മുടെ അസിസ്റ്റൻസ് ഓൺ ആവും. ഈ ബട്ടൺ പ്രസ് ചെയ്താൽ റോബോട്ട് റിലേ ഓൺ ചെയ്യും. അങ്ങനെ അതിന്റെ അസിസ്റ്റൻസ് ഓൺ ആവും. നമ്മൾ എന്ത് ഡൗട്ട് ചോദിച്ചു കഴിഞ്ഞാലും അത് ആൻസർ ചെയ്യും. ത്രൂ ഗൂഗിൾ API വെച്ചിട്ടാണ് അതിന്റെ വർക്കിംഗ് വരുന്നത്. പിന്നെ ഇവിടെ ബട്ടൺസ് എന്നുള്ള ഓപ്ഷനിൽ നമുക്ക് ആക്സിലറോമീറ്റേഴ്സ്, അതായത് ആക്സിലറോമീറ്റേഴ്സ് വഴി നമ്മൾ ഫോണ് ഷെയ്ക്ക് ആവുന്നതിനനുസരിച്ചിട്ട് റോബോട്ട് കൺട്രോൾ ചെയ്യും. അതിനാണ് ഈ ബട്ടൺ. പിന്നെ ഇത് റോബോട്ടിന്റെ ലൈറ്റ് ഓൺ ഓഫ് ചെയ്യാനുള്ള ബട്ടൺസ് ആണ്. ഈ രണ്ട് മെത്തേഡാണ്. ബട്ടൺസ് വഴി നമുക്ക് കൺട്രോൾ ചെയ്യാം, ആക്സിലറോമീറ്റേഴ്സ് വഴി നമുക്ക് കൺട്രോൾ ചെയ്യാം. ലൈറ്റ് ജസ്റ്റ് ഓൺ ഓഫ് ചെയ്യാണ്. നമ്മൾ ഫോർവേഡ് ബട്ടൺ പ്രസ് ചെയ്തു, അപ്പോൾ റോബോട്ട് ഫ്രണ്ടിലോട്ട് മൂവ് ചെയ്ത് വരും. നമ്മളിങ്ങനെ അതിന്റെ പ്രോട്ടോടൈപ്പ് എന്നുള്ളത് കാണിക്കാണ്. ബാക്കിലോട്ട് ഉള്ള ബട്ടൺ പ്രസ് ചെയ്താൽ ബാക്കിലോട്ട് നമ്മുടെ റോബോട്ട് മൂവ് ചെയ്യുന്നതാണ്. ഓഡിയോ ബ്രേക്ക് ഒന്നും ക്ലിയർ അല്ലേ?
ഓഡിയോ ചെറുതായിട്ട് ബ്രേക്ക് ആവുന്നുണ്ട്.
പറയുന്നത് ക്ലിയർ അല്ലേ?
കുഴപ്പമില്ല.
ഓക്കെ ഓക്കെ ഓക്കെ. ലെഫ്റ്റ് റൈറ്റിൽ ബട്ടൺ പ്രസ് ചെയ്യുമ്പോൾ നമുക്ക് റോബോട്ട് ലെഫ്റ്റ് റൈറ്റ് കൺട്രോൾ ചെയ്യാം. നെക്സ്റ്റ് ഫംഗ്ഷൻ ഈസ്, ഇത് നമ്മൾ എന്ത് ഡൗട്ട് ചോദിച്ചു കഴിഞ്ഞാലും ആൻസർ ചെയ്യും ത്രൂ ഗൂഗിൾ API. ഇത് നമ്മുടെ അസിസ്റ്റൻസ് ആണ്. അപ്പൊ നമ്മൾ ആ ബട്ടൺ പ്രസ് ചെയ്താൽ, അല്ലെങ്കിൽ ഈ ബട്ടൺ പ്രസ് ചെയ്ത് കഴിഞ്ഞാൽ അസിസ്റ്റൻസ് ഓൺ ആവും. ബട്ടൺ പ്രസ് ചെയ്ത് കഴിഞ്ഞു. ഇത് ഓഡിയോ, ഐ മീൻ റെക്കോർഡ് വീഡിയോ ജസ്റ്റ് പറയുന്നുണ്ട്. അതിപ്പം ഇൻസെർട്ട് ചെയ്യാൻ പറ്റാത്തതുകൊണ്ട് അത് കേൾക്കുന്നുണ്ടാവില്ല. അപ്പം ഇപ്പൊ അത് റെസ്പോണ്ട് ചെയ്യുന്നുണ്ട്. റോബോട്ട് റെസ്പോണ്ട് ചെയ്തുകൊണ്ടിരിക്കുകയാണ്. ആൻഡ് ദെൻ അടുത്ത ഫംഗ്ഷൻ എന്ന് വെച്ച് കഴിഞ്ഞാൽ കുട്ടികളുടെ അറ്റൻഡൻസ് എടുക്കുക എന്നുള്ളതാണ്. ഇതാണ് നമ്മുടെ ഫിംഗർ പ്രിന്റ് സിസ്റ്റം. പിന്നെ ഇതിനകത്ത് ഒരു LC ഉണ്ടാവും. അപ്പൊ ഇതിൽ നമ്മൾ ഫിംഗർ പ്രസ് ചെയ്ത് കഴിഞ്ഞാൽ അറ്റൻഡൻസ് എടുക്കും. ഇതിൽ നമ്മൾ NodeMC എന്ന് പറയുന്ന മൈക്രോ കൺട്രോളറും അതുപോലെ തന്നെ അത് വെച്ചിട്ടാണ് നമ്മൾ ഇതിനെ IoT വെച്ച് കൺട്രോൾ ചെയ്യുന്നത്. ഈ അസിസ്റ്റൻസിൽ നമ്മൾ റാസ്ബെറി പൈ വെച്ചിട്ട് പൈത്തണിൽ കോഡ് ചെയ്തിട്ടാണ് ഇത് ചെയ്തിട്ടുള്ളത്. ആദ്യം ഈ ഫിംഗറിനകത്ത് നമ്മൾ ഓരോരുത്തരുടെയും അറ്റൻഡൻസ് ഫിംഗർ എൻറോൾ ചെയ്ത് വെച്ചിട്ടുണ്ടാവും. അതിനുശേഷം ഫിംഗർ എൻറോൾ ചെയ്ത് കഴിഞ്ഞാൽ ഓരോ സ്റ്റുഡൻസിന്റെയും അറ്റൻഡൻസ് മാർക്ക് ഇതിനകത്ത് റീഡ് ആവുന്നതാണ്. ഫിംഗർ പ്രസ് ചെയ്തു. അറ്റൻഡൻസ് മാർക്കഡ് എന്ന് പറഞ്ഞ് കാണിക്കുന്നുണ്ട്. ഈ റീഡ് ചെയ്ത ഡാറ്റ നമുക്ക് എന്ന് പറയുന്ന സെർവറിൽ ഇപ്പം ടീച്ചേഴ്സിന് അല്ലെങ്കിൽ സ്റ്റുഡൻസിന് ഇത് മോണിറ്റർ ചെയ്യാവുന്നതാണ്. സ്റ്റുഡൻസ് പ്രസന്റ് ആയിട്ടുള്ളത് കാണാം. അങ്ങനെ ടീച്ചേഴ്സിന് ഇത് അവരുടെ അറ്റൻഡൻസ് മോണിറ്റർ ചെയ്യാവുന്നതാണ്. അപ്പം ഇത്രയും ഫംഗ്ഷൻസ് ആണ് നമ്മുടെ കംപ്ലീറ്റ് റോബോട്ടിനകത്ത് വരുന്നത്. And then coming to the slide. അപ്പം നമ്മൾ അതിന്റെ ഫങ്ഷൻസ് പറഞ്ഞു, അതിൽ സംസാരിക്കാനും ഡൗട്ട്സ് ക്ലിയർ ചെയ്യാനും പറ്റും. പിന്നെ വരക്കുന്നത് പറഞ്ഞു, പിന്നെ അറ്റൻഡൻസ് എടുക്കുന്ന സിസ്റ്റം, ആൻഡ് ദെൻ വിച്ച് വി ക്യാൻ കൺട്രോൾ വിത്ത് ആൻഡ്രോയിഡ് ആപ്ലിക്കേഷൻ. ഇത് നമുക്ക് ഇതിന്റെ റെലവൻസ് പറയുകയാണെന്നുണ്ടെങ്കിൽ നമുക്ക് കോളേജുകൾസ് അതേപോലെ തന്നെ ഇങ്ങനെ ഹാൻഡിക്യാപ്ഡ് ആയിട്ടുള്ള സ്റ്റുഡൻസിന് അവരുടെ സ്കൂളില് ഇൻസ്റ്റിറ്റ്യൂട്ടില് അവിടെയൊക്കെ ഇത് നമുക്ക് ഉപയോഗിക്കാം. That's all about my exhibition. Thank you.
Thank you. Now over to the judges.
So, okay, Muhammad, I appreciate your effort, but I have some queries.
Sure, sir.
Actually, a lot of Android devices and mobile phones are available, and by asking to that mobile phone, Google Assistant is there, Bixby is there, Siri is there, Alexa is there.
Yes.
So we can ask any question to that device, and they will give answer to us.
Yes.
So what is the need of this robot? Because it is a little bit heavy, and it cannot move like normal teachers. And also attendance can be taken by using Android phones.
Sure,
Okay.
sure, yes. Okay, so this is
So what is the relevance of this special robot? Only thing is that it can draw something, right?
yes. So
Can you give some explanation on that side? Okay.
Sure, sir. So in this robot, all these functions we are come up with a single product, and the Google API we created, or the talking system we have created, is it's only a prototype. So we can attach the same thing to the drawing system. So if we ask to draw a tiger with that system, it will draw a tiger. So that we can interface this speaking system to the CNC plotter, so that it will help to clear the doubts of the students, and as well as to draw the figures of the students. So all these together we combine with a single product, and also this is only a prototype, so that we can develop that into, we can add the projectors, we can add gestures, and also we can create the complete body part into 3D printing, and we can create it be a user-friendly robot. So the only thing is that we all these functions will combined to a single product, and also this speaking
But
system we can.
this robot is not handy, I think so. It cannot walk alone. Am I
No,
right?
it cannot walk alone. We can control with an Android application. We can move that too.
Okay, by controlling Android app, whether it is able to work.
Yes. I have shown in video.
So how many motors are used in your robot, and what about its degree of freedom and all those things? You have not touched that area.
I will show you, sir. This is the
Can you
working
show
system.
the video of the movement of robots?
Is it visible, sir?
Yeah, it is visible.
Okay. So this is backward and frontward movement. Now it is moving backward. This is a differential gear system. Here we have used two motors, two wiper motors of Maruti, so in which we so that which can handle more weight. അപ്പൊ നമ്മൾ മാരുതി കാറിന്റെ മോട്ടറാണ് യൂസ് ചെയ്തിരിക്കുന്നത്. അതിന് അത്യാവശ്യം നല്ല വെയിറ്റ് എടുക്കാൻ പറ്റും. ഇത് അറൗണ്ട് നല്ല വെയിറ്റ് വരുന്നുണ്ട്. അപ്പൊ പിന്നെ നമ്മൾ വണ്ടിക്ക് യൂസ് ചെയ്യുന്ന ഡിഫറൻഷ്യൽ ഗിയർ സിസ്റ്റം ആണ് യൂസ് ചെയ്തിരിക്കുന്നത്. അപ്പൊ എന്ന് വെച്ച് കഴിഞ്ഞാൽ ഒരു വീൽ നമ്മൾ കൂടുതൽ സ്പീഡിൽ കറങ്ങി കഴിഞ്ഞാലും അത് നോർമലൈസ് ചെയ്ത് കീപ്പ് ചെയ്ത് കൊണ്ടുപോയിക്കോളും. അപ്പൊ ഇത് കംപ്ലീറ്റ് ഡിഫറൻഷ്യൽ ഗിയർ സിസ്റ്റത്തിന്റെ ഒരു വൈപ്പർ മോട്ടറും ലെഫ്റ്റ് റൈറ്റ് ഡയറക്ഷൻ കൺട്രോൾ ചെയ്യാൻ ബാക്കിലത്തെ മോട്ടർ. ഐ വിൽ ഷോ യു. ഇതാണ് നമ്മള്
can you show me the movement of its hand while drawing a picture?
Sir, I will show you. The hand can't draw. There's a CNC plotter, sir. So the CNC plotter is drawing. The hand cannot move. I will show you.
Okay. CNC plotter is drawing. Okay.
Drawing.
Okay, then we need only CNC plotter for that purpose.
Yes. So all these.
What is the necessary of a robot like structure?
robot so that the students can interface and it will help them to give more interactions. And all these we can bind to a single product. That
Okay, you have some idea and you are taking some effort for that.
yes, sir. Yes, sir.
But you cannot answer some of my questions. Why? You cannot give proper explanation for the because already the devices are very convenient, but this is a
Yes,
huge
yes.
structure. That's why I have some queries. Okay, that's all from my side.
Okay, okay. Thank you, sir. Thank you.
Okay, Muhammad Rishan.
Yes, sir.
Same question from my side also. That is,
Yes.
what is the need of this big structure?
This is only a prototype, sir. This is only prototype developed for good appearance and good attraction. So I have told you that we want to create we want to create the complete body into 3D printing technology.
Now,
So that
only the additional facility which we provided is that plotting operation, and that can
yes,
be
yes,
done by a CNC plotter itself.
sure,
Then
sure.
there is no need of going for a big structure and unnecessarily adding the cost and avoiding the degrees of freedom.
Mm.
So,
So that we want to add on more things to this. We want to make this body into complete 3D printing and also projectors and gestures too. So that this is only a starting, and we want to add more and more.
well, there is for left hand and other parts there is no
Yes,
use. Only with
sure,
that
sure.
uh, plotting
Yes,
activity only performed. Then there is no need of
yes.
this big structure. What is the size of this one? Size, height, and
Around 178 centimeter.
what was the cost for
Cost
fabricating that itself?
So here we have used 3 microcontrollers and one microprocessors and complete body and differential gear system. So overall cost which is about 40,000.
So too costly.
Yes,
Mm.
sure. So if we create this complete robot into a 3D printer, it will come up with lakhs of rupees.
How much?
If we create the complete robot into a 3D printed structure and complete thing and a display in front of it, it will come around more than 2 lakhs.
Okay. So there is no need of displaying this big structure.
Sure. It's only an
Okay.
appearance and
So,
for showing.
with the help of PPT, you are not able to explain the things, including the drives, how that drives are working, how the links are working, that are not included in the PPT.
Yes, I have limited that. I have all those data.
So you didn't have shown any videos. If you are not showing showing it with the help of PPT, then with the help of that videos you can explain.
Yes, I have shown the videos. The drive video is it?
But that plotting operation and all and movement
Yes,
you didn't have.
movement I have shown, but plotting I have there is no option.
Okay, that's from my
Yes,
side.
okay. Thank you, sir. Thank you.
Again, very interesting. As the other teachers have mentioned, this particular robot is too heavy for a
Yes,
teacher.
yes,
You
yes.
see, your normal teachers are not like maybe these look more like what do you call the movie villains. So your normal teachers are not this much large, and also a person who's differently abled, how he will be able to or she will be able to take this robot to the class. It will be very difficult to transport because of the size.
Yes, firstly, I am repeating that we want to convert this robot into its complete structure, want to complete, and this is only a prototype. And the students can interface this with the CNC program control, and they can interface through the application.
Maybe I think you might have learned something by making this robot and the drives and all. So maybe
Yes,
you
sir.
can think of other applications for such giant robots. It's not maybe for teaching, we are now more or less online, and now even if the classroom sessions start soon, many of the teachers will have this kind of lecture delivery even in classrooms.
Yes, yes,
So
sure. This is mainly focused on these handicapped students
even for
for
handicapped,
helping us.
yeah, even for them, this is
Yeah,
the era of smaller, making things micro level and all. So
yeah, sure.
maybe
Yes,
this large structure and all may not be a good idea for such applications.
yes, yes,
You should think about it.
yes, yes.
Okay, thank you. Others
Okay,
have.
okay. Thank you, sir. Thank you. Thank you.
Now, without any further delay, I welcome Captain Donna Joy and team to present.
Good afternoon, everybody. Good afternoon, judges and teachers and my co-competitors present here. So this is a project that is the blind assistant. This is a fully established project, and I won't be able to come up with this project without my team members, that is Ria and Nivya. Ria is having some net issues, and Nivya will be joining with the PPT. Okay. We all know that blind people are unable to perform visual tasks. For instance, text reading requires the use of a braille reading system or a digital speech synthesizer, which should be available in digital format. The majority of published printed works does not include braille or audio versions. In this project, an innovative, efficient, and real-time cost beneficial technique that enables user to hear the contents of text images instead of reading through them is introduced. This is an upgrade to the existing braille system. It combines the concept of optical character recognition (OCR) and text-to-speech synthesizer (TTS) in Raspberry Pi. This kind of system helps visually impaired people to interact with computers effectively through vocal interfaces. I would also like to mention that this project is solely for the blind students. That is, we all know that blind students, they are shut out from the external world because of the constraints, that is, they cannot see. So they're not able to contribute to the society or get the privileges like basic privileges like education. Now I'll show you, okay, this is the braille system. Everybody knows about braille system. And these are the pictures that I've taken of the model that I've made. As you can see, this is the camera, Pi camera, and we have the Raspberry Pi with the SD card inserted, and then we have the goggles. Okay, coming to the hardwares required, we used Raspberry Pi 3B Plus, and right now we used an external power supply. That is, we just connected it to the power adapter and to our normal power supply. But if we have the money to purchase a Pi Juice hat, that is a rechargeable battery for the Raspberry Pi. It is compatible with the Raspberry Pi, and it is rechargeable. So if we can make that, then we don't have to use a power supply. So yes, so yeah. And then we have the camera module and an SD card with Raspbian installed. This is Raspberry Pi. Everybody knows about it, so I don't have to say. Yes, coming to the softwares required, we use the Raspbian for Raspberry Pi, Tesseract for character recognition and processing the image, and an OpenCV, that is a Python compatible library used in Raspbian and in many visual everything. And then we have TTS, that is text to speech, sorry. Yeah, and this is our block diagram. We have the Raspberry Pi, the power supply, the camera, power supply. We are connecting the Pi Juice. Pi Juice ad can be just connected, interface with the Raspberry Pi. Like it will lay over the Raspberry Pi. It can be interlocked. So we don't need any wires or any extra connections. It is fully compatible with the Raspberry Pi. Indeed, it's for Raspberry Pi. And then we know the Raspberry Pi, it has Wi-Fi, inbuilt Wi-Fi and Bluetooth. So we just have to use a Bluetooth earphone. And this was our prototype. Now we have an established product. This was our prototype. We have the goggles where the Raspberry Pi is kept inside, and the camera and earphones and the pipes. Now this is the making of our project. We first booted Raspberry, and then yeah, you can just go through the slides. Now coming to the first function of this project, that is the text detection. As you can see, this is a pre-uploaded text image, and this is the detected text image. I'll show you the video that I have taken from the model. This is the goggles with the Raspberry Pi in it and the camera here. And this is the speaker, and we have a display here. And when I run this, three things are going to happen. One is the picture will be displayed. Second, the text of the image will be detected here. And third, the text will be read out using the speaker. So I'm going to run this.
Hello, audio ഇല്ല കേട്ടോ.
Donna, can you increase the volume?
Okay, audio is not there. Okay. Okay, I can explain. Hello, I'm audible, right?
Yes.
Okay. So this was the initial setup of the text detection. And as you can see, we have the Raspberry Pi, the model here. And then we have the connection, see, speaker, and this is the program. And first, as you can see, I am showing a picture, and that picture will be text detected, and it is converted to the speech. So right now, this is this is me showing the text image, and this text image will be detected here, and it is read out from the speakers. As Meet is not allowing sound to come, you cannot hear it, but the speaker is actually reading out the text. Sorry for the. Then we have the yeah, same thing. There's no use without the audio, that's it. Okay, and now we have the face detection. That is this is a pre-loaded image, and as you can see, a bounding box will come. Okay. Sorry. Yeah, this is the audio was supposed to be there. This was contouring and everything we use in face detection. Okay. See, a bounding box is appearing on her face, and her name is being identified. Okay, we plan to use this in our model, and the blind person can identify people who they know, and they can get the data and name and everything, which will help them interact and communicate. Yes. Then we have the object detection. Here, as you can see, sorry. Yes, as you can see here, the objects such as chair. As you can see here, the objects such as chair, laptop, TV, monitor, etc. has been identified. Yes. Then we have the virtual blind speech assistant. I pass on to Nivya for the explanations.
Donna, can you play that video once again?
Yes, sure. Which one? The object detection or virtual
No, blind speech assistant with full volume. I think I can hear.
But okay.
Your computer volume also. Hello?
Yeah, can you hear?
Yeah, your computer volume.
Okay.
Can you increase that?
Yeah.
Okay.
Sorry. I maybe that is the problem.
So let me introduce.
Okay, now I can hear.
So let me introduce Amy. Amy,
I am ready.
introduce yourself.
I am Amy. I am your blind assistant.
Now I'm going to make her note down something.
What would you like me to write down?
The sun sets in the west.
I've made a note of that.
Next, we will ask her about our task. Amy,
I am ready.
what do I have on Saturday? What do I have on Saturday?
You have 2 events on this day. Yoga class at 7:30 am. Video conference at 8:30 am.
What do I have on February 22nd?
No upcoming events found.
Thank you.
My pleasure.
I have also attempted to make.
Okay.
And this is a cost estimation. This is an approximated cost estimation. Also, we are planning to make our own board. That is, we don't really require every property that a Raspberry Pi has. We can make a custom board which gives the output we want. So we firmly believe that that will reduce the price by a lot. And yes, the approximated total cost became around 6,000, but I firmly believe that making our own customized PCB boards can help us a lot. And these are the advantages. Nivya, I'll pass on to Nivya.
Okay, before that, I would like to explain those by Donna. It's about speech assistant. So a speech assistant made out Python language is also incorporated into our project. My assistant named Amy using PyTT-SX3, helping the user to note down calendar dates and schedule his meetings. Everything is given as an audio output to the user via earphones connected. Google Text-to-Speech is a screen reader application developed by Google for its and operating system. It powers application to read aloud the text on the screen with the support for many languages. Text-to-speech may be used by apps such as Google Playbooks for reading books aloud. Through Virtual Speech Assistant, we can access GPS, Google Search, etc. Now, with the help of a simple push button, a person can run the entire program. So in this way, Raspberry Pi based reader for blind helps a visually impaired to read a paper without the help of a human reader or with the help of tactile writing system. It helps to make their life hassle-free by detecting objects and recognizing the faces in front of them. The speech assistant is always out on the reach, even if there is no internet connection. Coming to
Sorry, continue. Nivya, you can continue.
Okay. Coming to its advantages, real-time text, fakes, and object detection, the Raspberry Pi based reader for the blind project has a simple and reasonably priced construction. It can be easily mass-produced in order to help blind people. The text detection recognizes both capital as well as small letters and numbers also. Python text-to-speech module is used, which is an offline cross-platform. Image processing algorithms are developed such a way wide variety of phones can be recognized, and it's also easily portable. It's applications in hospitals, home security applications, and 3D mapping, optimization of space utilization of self-driven cars, smart locks, and smart speech assistant. Next
I would like to make some new points, that is apart from Nivya's. We have some disadvantages here, that is good lighting condition and small range of reading, but there are night vision cameras available now, and also we can use good cameras having good range. So with that, I firmly believe that these disadvantages can be removed. Also, this speech assistant can be linked to the Google Assistant, which is already done, and with that we can get GPS and also the Google search engine. That is, the blind student can use the Google search engine with the Google Voice Assistant also. So this will make the life more easier, as by they can write notes, they can retrieve notes and everything. Pass on to Nivya.
Okay, talking about the future scope, if implemented on a large scale, this project would be helpful for blind students as it can be implemented in schools, colleges as a substitute for the Braille system. A mobile application using the same concepts of OCR could be made, which could be beneficial to people all backgrounds looking to access learning. And for the blind people to utilize their maximum hearing ability, we can incorporate headset through the bone, working on the principle of bone marrow conduction. The headset condense sound waves through the listener's skull bone by constantly vibrating the bone. This project could also be used as application of smart assistant. It could be used to aid old people who have lost vision with age. Donna, next PPT, please.
Okay, so here we would like to make a note that we have published this project in the International Research Journal of Engineering and Technology, and this is a certificate. And we have also received the copyright for our project. And I would also like to add on that we took part in the Inspire 20, that is the Kerala IEDC 20 for Ernakulam region, and we represented our college, Mar Athanasius College of Engineering, for the sake. Thank you.
Thank you.
Thank you, team. Now we can move to discussion with judges.
Okay. So you have already released your prototype, right?
Yes, sir. Yes.
So what about the cost of that prototype?
It costed 5,000 rupees.
5,000 rupees.
Yes.
Okay. So you have integrated the speakers on that specs?
Sir, the Raspberry Pi has got inbuilt Bluetooth. So we can just use a Bluetooth speaker. We can just wear it. No need to connect.
No need to connect. But while moving outside our home or outside our office, or moving to our office, we need to carry the speaker with us, right?
No, sir. We can use a earphone. Nowadays, everyone
Headphone.
uses. Yes.
With the help of headphone,
with the
we
neck
can.
band. Yeah. Yes.
Okay. What about the range of your device?
Oh, okay, sir. So our device basically has an inbuilt Wi-Fi. It can connect to any Wi-Fi sources in offices, schools, in our homes. And the
No. I am
Bluetooth. Yeah, Bluetooth.
asking
Yes, sir.
about the distance of obstacles it can detect.
Sorry, sir. I don't
That
remember.
depends on camera
Yes,
range.
Yeah, okay. What about the range of your camera that you have installed in that product?
it is a 5 MP camera, and the distance. I don't know, sir.
Okay. Please check on that. Okay.
Yes, sir. Surely.
Okay. I appreciate on your paper. You have
Thank
already
you, sir.
published
Thank you,
it.
sir.
Yeah.
Thank you, sir.
Okay. Okay, that's all from my side. Okay.
Thank you, sir.
Okay, very good project.
Thank you, sir.
Also, the prototype is being made, and some papers are published.
Yes, sir.
Okay. Then whether moving objects or obstacles can be avoided, or that information can be passed to the system.
I am sorry to say that is not there in our project right now. Right now in our project, we can detect objects, but we are trying to take it to a next stage, that is live detection, and it will give output such as there is an image, so and so degrees at a distance, like that voice we can get. That is there. Right now it is not there, but we are planning to take this to next stage where we are trying to implement.
Right now you are concentrating on some images and reading
Yes,
that.
sir. Yes, sir. Yes, sir.
Okay. Go ahead with your idea.
Thank you, sir.
Thank you, sir.
Okay.
Again, very good work.
Thank you.
So, I don't have question, but I have a suggestion.
Sure, sir. I would like to.
You have published your paper in a journal.
Yes, sir. Yes, sir.
But when you publish your work, you have to be very careful. You said you received your copyright. What is
yes, sir. We received that when we are publishing in the IRGET. First, they gave a form and we filled it, and yeah, that was the copyright. It said copyright. Let me see.
They gave you the copyright.
Yes, sir. Yes, sir. Yes, sir.
Okay. So anyway, but one thing is that there is something called the predatory journals. So you have to understand that journals of good quality are different. They may not accept your work without a proper review. The advantage of getting a review is that in spite of our looking it a couple of times, there may be minor errors, minor mistakes. So that will not be printed in our name. So if it is printed in our name, it will be a bad thing later on. It may not be, as undergraduate students, it may not be a problem. So always make sure that your quality work is published in good quality journals. Yes. Don't look for journals which publish your work quickly. That is actually not necessary. Yes. Good quality journals may take time. So please search for what is a predatory journal and what are the qualities required for good journals. So there are indexing services like Web of Science, for example, whose Science Citation Index is a recognized indexing. And this particular journal, if they are claiming fake impact factors are, you might be knowing that impact factors are based on the citations a journal is receiving over a period of time. So the highest impact factor currently may be for the journal Nature or maybe for Science, it may be nearly 50. So even very good quality journals in maybe say robotics or maybe aerospace and all may not have a very high impact. So if somebody is claiming very high impact factor, you have to verify whether it is from a proper recognized source. And also in predatory journals, you may have people in the editorial board who are actually fictional. They may not be real. If you look up for them, you may not find them with proper affiliation and proper in the university website, and how you may not find. So there are many such journals operating out of India. Now you might have come across articles in newspapers and all. There are many such journals coming out from India and China, especially these two countries. So the problem is that we may not be aware of that, but when you present your work to somebody who is aware of it, most of you might be trying for higher studies. Some of you may be interested in trying for higher studies abroad. So at that time, papers published in good quality journals only will count. So therefore, you have to take that pain. Don't go for fast publication. Make sure that the journal is good. Even if your paper is rejected by a good quality journal, it will be rejected with a lot of advice and a lot of comments and suggestions. Using those advice, those comments and those suggestions, you can revise your paper and submit to some other equally good journal. So always make sure that you go for some good quality journals published by reputed professional bodies or reputed publishers. And that will also ensure that maybe 20-25 years down the line, you can show your children that this was our first paper published in this journal. But in a predatory journal, this may disappear from the online platform. So maybe after 5 years, when you are applying for a PhD program, you may not find it there. So these are actually my suggestions from my experience. So make sure that your effort is not wasted in some predatory journal where your paper will be appearing with some non-reviewed paper which might have been copied from somebody else or plagiarized from somebody else. So that is my only suggestion. Otherwise, it is a very good quality work.
Thank
So
you, sir.
continue with it.
Thank you, sir. That was really valuable. Thank you, sir.
Thank you, sir.
Thank you. Now I welcome Captain C.V. Sriram and team to present.
Yeah, thank you, Arundhati. Renu, can you share the screen and do the presentation?
Yes. Oh, is it visible?
Yeah, it is visible.
Okay. The slide is visible, right? And am I audible?
Yeah, you are audible and the slides are visible.
Okay. So, hello everyone, good afternoon. We are here to present our idea under the theme Aid for Differently Abled by adding a feature of reverse gear in the handicapped scooters. So, our team members are myself, Renu Maria, Sriram CV, Rohit, and Bastin Joseph Mannarat and Edwin Justin. So, getting into our topic. Firstly, talking about the objectives of this project. Well, the prime objective is to provide safety and ease to the physically challenged people while riding the handicapped scooter, for which we are trying to implement a reverse gear mechanism in such scooters. And it will help them very much as it has a very valid practical application. Now, another important aspect is why we need this project. Why is it a necessity? For a physically challenged individual, it might be very difficult for them to move back or even take a U-turn. But with this reverse gear mechanism, it becomes simpler and effective. Main aspects of our presentation is its working principle, obviously the main foundation. Materials required, its expenses, and we also are providing a small working CAD model of the electric gear train used for this project. So, getting into the topic, firstly the working principle, and it's the basic foundation of this project, and I'll be here explaining how this project works. So to obtain a reverse motion, which is our ultimate requirement, we need to reverse the direction of the shaft, which is why we are using an epicyclic gear train. And for the same, this epicyclic gear is attached with the lever. So when the user pulls the lever, the gear is engaged and the direction is reversed. And when the shaft is pushed, which is done by pushing the lever back to its initial position, the gear is disengaged, and thus a forward motion is reobtained. So for better explanation, we have given the figure. This diagram is again of a epicyclic gear, which is the main component of this project. It consists of a sun gear, which is in the center, and as you can see, you have 3 planetary gears, and you have the ring gear at the outside. The planetary gears are meshed internally with the ring gear, so they rotate in the same direction as that of the ring gear, and whereas the sun gear rotates in the opposite direction. So therefore, you can see that whenever the input motion is clockwise, the output motion becomes anti-clockwise. and vice versa, so that the input and output are in the opposite directions. And therefore, our requirement, that is the reversing of direction, is obtained. And on the financial and talking about the expenses and cost cuttings, to make the whole system more economical and cost effective, we do not change any inner mechanisms of the scooter. We simply add an additional attachment, which is the gear train, and there is no change in the engine, therefore making the process and result simple yet effective. So for as of the material requirements, the main requirement as said before is the epicyclic gear train. Its figure is given on the right side. The figure on the left side also shows the transmission of a scooter, transmission in a scooter, which is the basic diagram. Now, talking about the expenses. So, as for the expenses of the overall project, it is estimated to be around 4,000. The exact prices are yet to be found out because of the present scenario not being on our side. And other requirements are the lever, which is used for, as said before, disengaging and engaging the lever, engaging the gear, sorry. And other workshop facilities like cutting, welding, and grinding are to be done. So all of these are the materials required and their respective expenses. Now, for better understanding for the viewers, we would also like to add a CAD model of the epicyclic gear train, which is used in this project mainly, and it is used and it is designed by using the software called Fusion 360, as mentioned. So let's view the video. Can everyone see this video?
Yeah, it is visible. I think you have to click on the play button.
Yeah, it's coming right up. So as you can see, this is the CAD model. You have the sun gear as explained before and the 3 planetary gears, and you have the ring gear. You can see clearly that when the planetary gears are moving in the clockwise direction, ring gears are also moving in the clockwise direction, whereas the sun gears alone moving in the anti-clockwise direction. So I hope that this gives a clear idea of the epicyclic gear train used in this project, which is the main additive. Thank you for your patient listening. Thank you.
Thank you, team. Now over to the judges.
Okay, Renu and Sriram.
Yes, sir.
Yes, sir.
Okay, you are fixing this to a Honda Activa like scooter, right?
Yes, sir.
Like
To any handicapped
scooty
scooter.
type. Yeah, scooty type. But where will you fix this? Where is the exact position of this epicycle gear?
Sir,
Actually, the scooty type consists of a CVT, continuously variable transmission.
Yeah.
And a belt. So where will you fix this?
Sir, by removing the rear wheel nut, we are planning to fix there an epicyclic gear. So only this additive has to be provided to reverse the direction of the shaft. When you pull the lever, this will engage, and when you push it back to the initial position, this will disengage. That is how our idea is.
So how will you transmit power from the engine to the back wheel?
Sir, the power is already being transmitted, and there is no change in the power transmission. But there's only the only change that takes place is at the rear part of the wheel, just near to the wheel nut, where when the lever is pulled, it will engage and reverses the direction, and everything else is the same as that of now.
That part is a little bit confusing because there is only one shaft, and to that shaft the belt is provided.
Sir,
right.
Not that place. The shaft and the gears are.
Do you have any diagram showing the exact place of the your device?
Device. Renu, can you take the
Do you have any sketch?
Yes, yes.
that actual transmission in the scooter? Page 9, I think. Yeah.
Not this, not this.
No,
Yeah,
that
yeah,
one.
yeah.
There is the rear wheel.
Zoom it. Can you zoom that portion? Hello.
I don't think you can zoom it.
Actually,
Okay.
I
Zoom in.
Can you
made
see?
this picture. I made this picture. That's why I am
Yeah.
asking.
Okay, sir.
But it is not visible.
Sir,
okay. It is nearer to that engine side, right?
Yes, sir.
We are fixing, not at the wheel end.
No, sir. We are fixing at the wheel end, rear wheel end.
But
So there is another. Yes, sir.
Sketch is confusing.
So this is the actual transmission.
Actually, I am a mechanical engineer. That's why I am asking the details.
Yes, sir. We are providing that right side image. It shows the epicyclic gear that has to be included in the current one.
The actual transmission of the scooter.
Yeah.
You are providing it at which portion?
Sir, we took this picture from a YouTube video which shows the transmission.
So where is the epicycle gear train?
That hasn't been included in the left side image.
So that is the main problem of this presentation. You have not shown the exact position of the epicycle gear train, because I know what is happening there. Actually, in a scooty, what is happening there I know. So I am confused about the position of the epicycle gear train.
Sir, rear wheelന്റെ wheel nut മാറ്റിയിട്ട് അവിടെ വെക്കാന്നാണ് ഉദ്ദേശിക്കുന്നത്.
Wheel nut മാറ്റി അവിടെ വെക്കുകയാണെങ്കിൽ നമ്മുടെ ബെൽറ്റ് ഡ്രൈവ് എവിടെ കൊടുക്കും? ബെൽറ്റ് ഡ്രൈവ് കൊണ്ടല്ലേ വീല് റൊട്ടേറ്റ് ചെയ്യുന്നേ.
അത് സാർ, പക്ഷെ എന്നാലും അവിടെ കുറച്ച് ഗിയർ
ട്രെയിൻസും ഷാഫ്റ്റ് അപ്പം നമ്മള് അഡീഷണൽ വർക്ക് ചെയ്യേണ്ടി വരുമല്ലോ. യു ഹാവ് ടു പ്രൊവൈഡ് അഡീഷണൽ ഷാഫ്റ്റ് ടു ദ ഫ്രെയിം. ദാറ്റ് വിൽ ഇൻക്രീസ് ദ കോംപ്ലക്സിറ്റി. അല്ലേ? നിങ്ങളത് നോക്കിയില്ലേ ശരിക്കും? അങ്ങനെ ഒരു പ്രശ്നമുണ്ട്. അതുകൊണ്ടാണ് പിന്നെ റിവേഴ്സ് ഗിയർ സ്കൂട്ടറിൽ വെക്കാത്തത്. അല്ലെങ്കിൽ മാനുഫാക്ചറേഴ്സിന് തന്നെ പിന്നെ ഈ ഹാൻഡിക്യാപ്ഡ് ആൾക്കാർക്ക് ആ പൊസിഷനിൽ വെച്ച് കൊടുക്കായിരുന്നു. ഇത് സിമ്പിൾ. ബട്ട് യു ഹാവ് ടു കം അപ്പ് വിത്ത് ദാറ്റ് ഐഡിയ. യു വേർ ടു ഫിക്സ് ദി epicycle gear train.
The position, right?
Yeah. This is confusing. If you have any diagram or sketch, then it's okay. Because the shaft to the wheel is connected with the belt. If you add any additional components, you need to where to fix. Actually, this epicycle gear also have to connect it to the frame. It cannot fix it to the space. It cannot stand there. Gravity ഒക്കെ ഉള്ളതല്ലേ, താഴെ പോകില്ലേ. അപ്പൊ അത് ഫ്രെയിമില് എവിടെയെങ്കിലും പിടിപ്പിക്കണ്ടേ എപ്പിസൈക്കിൾ ഗിയർ ട്രെയിന്?
സർ, റൈറ്റ് സൈഡിലെ ഇമേജിലോട്ട് അത് റൈറ്റ് സൈഡില് താഴത്തെ ആ ബാർ ഡ്രാഗ് ചെയ്തത്. ചെറുത് അകത്തോട്ടും പുറത്തോട്ടും പോകാൻ പറ്റുന്നൊരു സംഭവമാണ്. അപ്പൊ
ഫിക്സ് ചെയ്യുന്നത് എങ്ങനെയെന്നാണ് ഞാൻ ചോദിക്കുന്നത്. സ്കൂട്ടറിൽ എങ്ങനെ ഫിക്സ് ചെയ്യുന്നത്?
This is just an idea.
Your idea is good, but where to fix this one?
Sir, this is just an idea. We haven't practically done this.
I am not convincing you. എന്റെ കൂടെയുള്ള സാറന്മാർക്കെല്ലാം ഈ ഒരു ഡൗട്ട് തോന്നിയിട്ടുണ്ടാവും.
Okay.
അപ്പൊ അങ്ങനെ ഒരു സ്കെച്ച് ഇറ്റ് ഇസ് നോട്ട് there. Okay. I appreciate your effort. Nice idea, but you have to look into that details also.
Okay, sir.
If there ഒരു സ്കെച്ച് ഉണ്ടായിരുന്നെങ്കിൽ okay.
ആ
എല്ലാം ക്ലിയർ ആണ്. എന്നാലും എനിക്ക് കൺഫ്യൂഷൻ നിൽക്കുന്നു. ഓക്കെ, ബട്ട് മൂവിങ് ടു അതർ ടീച്ചേഴ്സ്. ഓക്കെ,
okay sir.
ദാറ്റ്സ് ഓൾ ഫ്രം മൈ സൈഡ്. ഓക്കെ.
Okay, Sriram.
Yes sir.
You have to include the sketch. With the
Sketch.
help of sketch only, you can it will be able to understand whether it can be fixed, whether the parts where it can be mounted, all these details. Also in the simulation, you have shown the simulation for an epicyclic gear train, and
Yeah.
the dimensions. What are the dimensions you have used?
Sir, the dimensions can be varied because according to the speed ratio, the gear ratio has to be changed. So it depends on the user, and I think that only for reverse gear we need the speed ratio need not to be very large because we are only using this epicycle for obtaining reverse motion. So it depends on the speed ratio of the requirement of the user.
So you didn't have designed that one. You have downloaded some epicyclic gear train.
No,
in the net.
the epicyclic gear train, that video shown was designed by our team members.
Then you will be having some dimensions for that, at least for that one.
Yes sir, but we mainly focused on showing how to reverse the shaft motion.
Actually, you have to include that mounting details also.
Okay sir.
Where it can be mounted. Then the size requirement will be a big problem. Size of this epicyclic gear will be a big problem during that time.
Yeah. But when it comes to the handicapped scooters, there are 2 wheels in the rear part, so the size may not be a problem. But if it was the case of an actual scooter, the size could have been a problem. But since we have 2 rear wheels at the back, it needs that much of space.
But that 2 rear wheels move independently. It has no connection with the wheels of the actual scooter. Okay, it is an extra fitting.
But there are some scooters in which you can only see 2 wheels in the back side, right?
So then we need a differential.
Yeah.
Okay,
sir.
Sriram.
Okay, sir.
Anyway, the 2 teachers are experts. They have asked the queries. I think people use the term, but I am a little bit confused. Why it is called handicapped scooter?
They are being used by the handicapped people, right? So
But
it needs to have a support.
But basically, this implies the scooter is handicapped. Right? The term usually, maybe people will be using, I don't know, but when you look at your heading or your topic title, handicapped scooter means the scooter is somehow handicapped. So,
sir,
usage may be there, right? I don't know.
Yeah, I think if you Google it, you can see some of the pictures related to that.
But I don't know whether it is correct or not. While we Google, we get a lot of information. But when we give a paper title or something, we have to be a little bit careful. So I don't know whether this usage can be right or you please check. I think scooter for the handicapped will be, or maybe scooter for the differently abled will be a better. Even handicapped is not correct nowadays because of sensitive issues. Sensitivity to different able people, we have to consider the use of words. Anyway, I don't have any more comments. Thank you.
Thank you, sir.
Thank you, team. Now, I welcome Captain Sony John and team to present.
Hello, am I audible?
Yes.
Good afternoon. My name is Sony John. I and Dhanush from our team will be presenting on the topic 8 for differently abled. So the name of our project is Mano Amica. It's Italian for helping hand. And the problem we are addressing through this project is that there are currently about 3 million arm amputees in the world, out of which 2.4 million are from developing countries like India, majorly from India. So out of this, only 5% of the amputees have any kind of or some kind of access to prosthetics. And out of this 5%, majority is from developed countries. And even in this 5%, who have access to prosthetics, they use cosmetic prosthetics. And
Excuse me, are you showing a presentation?
you couldn't see? Oh, sorry.
I'm not able to see.
One-
Others can see or not?
No, it is not present.
Sir, can you see now?
Yeah, it's coming.
Sorry.
No problem.
Okay. Should I start from first onwards? Okay. There are actually 3 million arm amputees in the world, and out of which 2.4 million are from developing countries like ours. And out of this many people, only 5% of the amputees have any kind of access to prosthetics. And out of these 5%, majority is from developed countries. And even in this 5%, majority of the people use cosmetic prosthetics. So let's search what is cosmetic prosthetics. These are just body replacement parts which does not have any functionalities. People just put on what's remaining on their put these on what's remaining on their arms just to fit into society without any functionalities. And that is used by most of the amputees now. And the sadder thing is, even with big players in the field of prosthetics like Autobot, studies shows that there will be only 18,000 prosthetic arms available in the next 50 years. That means that majority of the population, almost 99.5% of the current amputee population, will not have access to any kind of prosthetics in the next 50 years. In this technology, in this age of technological advancement, 99.5% of a sector of a population will not have access to any kind of prosthetics. And even in India, in the working population, there are about 1.1 lakh below elbow amputees. So this is the problem we are trying to address. Now let's see what are the available solutions currently available in the market. And then you can see what is the second part of the problem statement. So this is a below elbow prosthetic arm, which is powered by a cable seen here. So this is manually operated mechanical prosthetic arm, and it costs 25,000 rupees. It doesn't have any involuntary functions, and it costs 25,000 rupees. The next one, which has a simple open and close grip, has cost 90,000 rupees. And when we are looking at the premium products, it costs 8 lakh rupees, 15.77 lakh rupees. And some of the major giants like Autobot charges $10,000 to $50,000 in for their prosthetic arms. So this brings us to the second part of the problem statement. An average Indian earns about 30,000 rupees in a month. These functional prosthetic arms available in the market in India cost many times greater than the per capita income of our country. So this is the problem we are trying to address. We are not trying to bring a sophisticated prosthetic arm. We are trying to bring a sophisticated prosthetic arm that can be accessed by an average Indian. So these are the broad objectives of our project. First one is to make a prosthetic arm which will be able to meet most of the users' day-to-day activities. We accept that the field of prosthetics will not be able to replace an original human arm in the next few years, at least for the next few years. But what we can do is study and analyze and take and find the most usable grip patterns and tend to that and provide the users with those facilities, and that's what we are trying to do. And the second point is that we are trying to build a prosthetic arm that is affordable by an average Indian. And yes, the third one is to build upon the existing technology used in the field of prosthetics and to make it economical. So moving on to our project. So this is the CAD model of our project. Let me zoom in on that. So this is the CAD model of our project. And the thing is, in the majority of the prosthetic arms that is available in the market, the motors for the servo motors for the arm is fitted in the palm of the hand to get more torque. But what this means is that the motors should be small but have enough power and should be much more efficient, and this causes the motor cost to go high. So this causes the price of the prosthetic arm to go high too. So in the right, you can see the exploded view of the prosthetic arm. So what we have done here is we have created an artificial tendon networks, just like we have seen, not just like that. This is inspired from the tendon network seen in our hands. As you can see, in the anterior view, there are tendons that cause the flexion that flexes, and this causes the causes our wrist to close. This causes our fist to close and open. So we are applying the same model to our prosthetic arm. What we have done is we have created holes in the model, and where we can insert the artificial tendons, and this is connected to a motor, servo motor and a spindle. So say the motor spins to the left, there will be an applied force here, and the finger closes on itself. And if the motor rotates counterclockwise, the wrist opens, the palm opens. So that is the mechanism of that is a mechanism we are using for the project. And this is the sample of the stress analysis we have done, and we have checked the feasibility of 3D printing this product in this slicer, and it turns out okay. And moving on to the material properties, we are using ABS plastic. So we have considered many other 3D printing material for this product, but for our needs, the ABS plastic turned out to be the best, so we are choosing that. And you can see the criteria we used for choosing ABS plastics. And moving on, so this is a large project, and we have just begun on our phase 1. And the phase 1 is to model our arm, to prepare a CAD model of our arm, which you just saw, and to prepare a flexion and relaxation to open and close the fist, just a opening and closing of the wrist of the arm. So let's see, this was our first model of the prosthetic arm. So it costs a lot of material, so we then created another model that uses less material and has and is much more functional. You can see the CAD model on the screen. So for the signal processing, we are using an EMG sensor. What the EMG sensor does is it is attached to the what's left of the amputee's arm, and once a signal is received in this arm, the surface electrodes seen here will pick up on that, and if that exceeds a threshold limit, it means it shows that the when a person, when an amputee causes a muscle to flex there, it can pick up on that, and that can cause the servo to move. So this is the basic circuit of what we are trying to make. This EMG circuit will pick up on the electric signals from our nerves and will give it to the Arduino board. And then if the value crosses the threshold limit, the servo will begin to turn. And in the real project, we are going to use multiple servos and multiple EMG sensors. This is just a basic circuit, and here is the schematic for the same. Here we have used a voltage divider circuit to get the 5-volt required 5 voltage for the EMG sensor from the 9-volt battery we are using. 7-volt battery, 7.4 volt battery we are using. So now moving on to specifications. So we have calculated the weight of the prosthetic arm, and it turns out to be 510 grams, and this is well under market standards. And the maximum load it can carry is 1 kilogram. So the calculations for the same will be provided in the next slide. And this torque of the servo motor we are using is 15 Newton meter, and it can travel, like it can move 120 degrees in less than 0.4 seconds, and this causes the arm to arm to be very responsive, and that is a very good thing. And the battery we are using is a 1000 mAh battery, and if we are running one servo, for just the opening and closing, all we need is one servo motor. So if we are doing that, we can have a 5.4 hours max continuous running of this prosthetic arm. So no one is going to use this prosthetic arm continuously for 5.4 hours, like opening and closing for continuously for 5.4 hours. So if we are calculating on an average, we can get up to 12 or maybe up to days of battery life in this product. So for the calculations of the maximum load, you can see the calculations on the screen. So on average, a single fingertip can hold 150 grams, can lift up to 150 grams, but we are using 3 servo motors. You can see that we have given space for 3 servo motors, and that amounts to approximately 1 kilogram. See, the 150 grams is for in the open position when the finger is at the extremest position. When the finger closes on itself, the distance decreases and the force that can be applied can increase up to 2.5 times. That is why there is a 1 kilogram limit. And this is the main part of our presentation, the cost. So as you can see, what we have shown earlier is the same functionality of the prosthetic arm, which costs 90,000 rupees. And we have taken inventory of the products that we will be using, and it costs, like, this is the most conservative budget we have put. Like, we have planned for major contingencies and taken many steps for that, and even that cost only 8,466 rupees. We have not included 3D printing costs because we didn't get an exact quote on that. We were planning to build our prototype in the fab lab of our college. So that's it. But this is just the tip of the iceberg. This is just the starting of our project, and what we are trying to do here is, in our future, we are trying to bring in multiple grip patterns. So a simple opening and closing won't be enough, we know that. So we are planning on bringing multiple grip patterns. Actually, we are doing a study on the use cases of the arms, like what all major activities we are using our hands for, and what all positions, what are grip patterns that can be classified into, and we will be selecting the most needed grip patterns, and we will be applying that to our model. And the next point is to build our EMG sensor. So you can see out of the 8,400, 3,000 is for a single EMG sensor. So we are trying to build an EMG sensor. We are studying the market. We are studying the available products in the market, and we will be building our own EMG sensor that can drastically reduce the cost of the EMG sensor, and this enables us to add more sensors into the arm, so that we can have an 8-channel EMG sensor which can get an all-around data from the arm. And the third one is the user customization and calibration. We want the user to be able to choose his own grip patterns from the available grip patterns, and we want the product to learn from itself, to learn from the user and adapt to it. We are going to deploy a neural network for signal pattern analyzing, and that will help in making the product better day by day. And at last, we want to create a wide portfolio of budget-friendly prosthetics for various types of amputations. We have shown only the transarterial amputation products, but we want to expand this into multiple amputation products. We want to do in upper extremities and lower extremities also. In short, we want to democratize the field of prosthetics. Thank you.
Thank you, team. Now over to the judges.
Okay. Sony, are you alone in this project?
No, sir. There are multiple people working, and there are almost 10 to 15 people working on this project. Danish is here with me for the presentation, sir. He is handling the mechanical team.
Okay, you are from the mechanical side.
No, sir, I am from the electrical side.
You are from electrical side. So actually, this robotic arm, I think, is it the correct word for?
Myoelectric prosthetic arm is the exact word.
Myoelectric prosthetic arm. Okay. Only two motions are there, closing and opening the arm.
For that, just in the phase 1, we are just trying to build a model that actually works, and we are trying to find the what all possible difficulties we are going to face. We are finding that, and once we do that, we can go into are using several servos, and this can be attached to several fingers, and this can give independent motions to each fingers. So we can have a tripod grip or something. We can expand this into many stuff.
So the mechanism is receiving signal from the brain.
No, sir, not from the brain. From the yes, the signal is coming from the brain, but we are receiving it in the end part of the arm, where the amputation occurred. We are receiving the signal from that part.
Okay, by the movement of the muscles, from the movement of the muscles.
Yes.
Okay, and what about the material that you are using here?
So we are using ABS plastic.
ABS plastics means?
It's acrylonitrile butadiene styrene. It's a plastic. It's mostly used to 3D print. In 3D printing, ABS and PLA is widely used. But here we use ABS because it has more strength to density ratio than PLA, and high resistance and hardness.
Okay, what about the compatibility with the amputated arm? Amputed portion.
So ABS, we chose ABS for another reason, because it has no known reaction to the human arm. Like it doesn't have any allergic reactions or causes harm to the human arm. And we are planning to use a socket for that. Like it can be adjusted to each person. Every arm is going to be different. Like every type of amputation is going to be different. So we have to customize the socket for the person according to each according to their amputation. So we are currently working on that.
Okay. Over to other teachers. Thank you. Okay.
Thank you, sir.
Hello, Sony. Nice project idea. Then how from the muscles, how these instructions are transferred, how these commands are given?
So this EMG sensor, like what it does is that, like when our nerves gives out electrical impulses to these tendons, the tendons I have shown here. So these tendons, when they receive these electrical signals, they tend to contract and relax, and this causes the entire arm to move. So with these electrodes in this EMG sensor, I can show with these electrodes here and here, what we can do is that we can detect the electrical signals even at the surface of the arm. So that signal can be received and it will be processed in this EMG sensor. The available sensor processes it and gives out an analog voltage from 0 to 5 volt, which is the working voltage of the EMG sensor. And according to the magnitude of the signal comes, we can actually put out a proportional control for this motor, so that it can provide that much the needed torque for it.
How it will differentiate whether the signal will be given to the different portions?
Sir, this prosthetic arm, for the transardial amputation, that is below elbow amputations, when we are giving we have to flex our muscles hard. We have to flex our muscles in order to get a signal from this amputated portion. So when this muscle is flexed, there will always be noises and all, and we will be applying a filter for the filtering out noises, and we will be rectifying it. And we are trying to find the right frequency. Yes, this ready-made sensor always finds the right frequency, but we are also trying to make our own EMG sensor that finds the right frequency of the EMG sensor and deletes all the other noises, and that can be used for analyzing the pattern of these open signals, like the EMG signals coming from the hand, and that can be given to the Arduino.
What about the reliability of this product compared to the one you have shown? Around 90,000 rupees you have shown, and now the cost is around 8,000 rupees only. And
that is without the 3D 3D printing will add some more to that.
Okay.
So there is not much. You can search for yourself. Like there is not much addition. Like the only thing is that these are technologies from like before 3D printing comes. These are like age-old technologies. These have not changed much. The other products which have been shown, like the ones that cost 15 lakhs and all, they have added some more features. Like they have added sophisticated EMG sensors. The EMG sensor is the heart of this project, because larger the data we get from the hand, the larger is the diversification we can bring to the grip patterns. We can include more and more grip patterns. But these products that we have shown provides no advantage of over our product, and other than the material use, and that is not advantageous. I think that is just old ideas still in existence.
Okay, Sony.
Again, very interesting. But I have a little concern about the group. You said that there are 15, 20 people in the group and also interdisciplinary. So, as far as the organizers are concerned, I don't know whether it is a level playing field with the smaller groups having limited thinking capability with few number of people in their team. So, with 15 to 20 smart people in your team, you will naturally be able to do better than the others.
One small correction, like we are starting our project, we are trying to recruit more people. We, like you can see that we have not yet started. Like this was started with 5 people and we are currently under the process of recruiting more.
So you are now only 5 people are there.
Yes, this entire project is the work of 5 people and we are currently recruiting more and more people to this project can't be done by like what we are trying to achieve can't be achieved by only 5 people. We want more and more people in our group to build what we are trying to build.
Okay. Then another thing is, what are the technological gaps that you have identified so far which may prevent you from developing this quickly, indigenously and quickly?
Technological gaps. Yes, one is the funding, of course. The product itself costs less, but when we are trying to build that, we may have to run different trials and all, and this may cost some more. And the EMG sensor.
No, in the sense, is there anything that you not need to learn a little more so that you can complete this project?
Yes, sir. There are much more things to do in this sector. Like
what are those things? Have you identified those things?
Yes. Yes, like I said, the EMG sensing, the signals what we are receiving. Like we don't want, we want the hand to move according to what the human wants. So for that we need to get more and more signals. But the EMG sensor we are currently having costs 3,000 and gets only one signal from a single muscle. Our arm has numerous muscles, and we can't acknowledge. We can't make different gripping patterns with just one single EMG sensor. So we have to apply we have to apply a sophisticated. We have to apply a very sophisticated machine learning algorithm in order to.
So do you know how to prepare or write a machine learning algorithm?
Our one team member, Fabian Chatton from our team, is a MCA student and he has worked on many projects in the machine learning.
Okay, so you have a person who
is
interested with that task.
Yes, sir.
So then you have shown many prices. There is something called GST.
Sir,
have you considered that also?
Sir, once more.
You are showing many cost prices and all, right? Equipment prices. So there is something called GST. Have you included that in the calculations? GST.
Sir, I think it's just it doesn't have it's even if we haven't we haven't considered the GST, but the maximum GST is 28% or something, right? Like 28% of 8,000.
Why it is important is, suppose you submit this for some funding or maybe even some sponsorship or something, then you need to estimate the cost correctly. That is why.
Okay, sir. We haven't looked into that. Then we will look into that.
Yeah. Then do you know how this servo motor functions? How do you know how operation of servo motor? How to make it work for your requirement?
I don't I haven't studied the inner mechanisms of the servo motor. But
no need for inner mechanism. Your application.
Yes. For we have to first we have to build we have to provide a tender network, and we have to create that just right without any loose without any looseness in the string, and it can rotate up to 0 to 180 degrees, right?
So how you order a servo motor for your requirement? How will you decide that this particular servo motor is
So for that,
sufficient?
in that, like for our first phase, we have selected a simple servo motor from the online marketplace, and that was enough for this model. But we haven't thought of what we are going to do, like whether to customize that or not.
So I think even though we are all under the lockdown, unfortunate situation, these things can be done. So these computations and all you can do because it won't require you to come together physically and all, right? So I think these things you should move quickly during this lockdown period, so that by the time if it is lifted, you will be ready.
Yes, sir.
Thank you.
Thank you, sir.
Thank you. Now I welcome the last team, Captain Jeremy, Jens, Reggie and team. Jeremy, Jens, Reggie, are you there? Yes.
We don't see such a name in the list.
Yes, sir. So we'll conclude the program now. All of you have done a great work by coming up with new projects in aid for differently abled. The hard work and dedication of each and every one of the team members were clearly visible in the presentations. I, on behalf of College of Engineering Trivandrum, would like to give a huge round of applause to all of you. I would like to thank all the judges, Abhilash sir, Shafiq sir and Pradeep sir for the dedication and skill when it came to judging of Project Expo. Without your generosity, knowledge and patience, the session would not have gone as smoothly as it has. Once again, I thank you for your services and spending your valuable time with us. So, we have come to the end of Project Expo running under E-Novus, authorized by Innovation and Entrepreneurship Development Center in association with Institutions Innovation Council. All the teams did a great job in bringing very innovative projects under the topic Aid for Differently Abled. Now, I would like to thank all the hands that worked together in making the Project Expo a huge success. I wish all the best to all creative minds here. With this, we have come to the end of this year's Project Expo. Once again, on behalf of College of Engineering Trivandrum, I thank you all. Have a great year ahead.
Thank you for inviting us, and also congratulations on organizing this very efficiently. Thank you.
Thank you, sir.
Thank you.